Uh, Good evening, students. I'm Satish here from Pragyan AI. Before we start the workshop on deep learning, it is a 15 days, 15 session workshop. Uh, it First week we will cover about introduction to deep learning. Second week we will please mute ground rules actually, like please mute. Lot of people are muting. Good evening, folks. Please mute. If you have any questions, please type into chat window, uh, because we want to be students should be not disturbing others who are interested to learn. And any questions or any doubts, if you have, you can raise the flag. You can raise your hand and type your question, and I will address and I will go ahead. But please, at any condition, do not uh, on your mic actually. So be in mute stage actually. Okay. Let me give briefly introduce about Pragyan AI. Pragyan AI is a startup which is focused on data science and AI. We groom the students from any degree, BCA, BSc Computer Science, and any B branch uh, into data science and AI comprehensive program. So there is a 2 years, there is a 3 years kind of program. So it is the curriculum is something equivalent to NIT kind of curriculum, like top-notch curriculum, and taught by industry experts like me and other fellow faculties. So I have around 18 years experience after my masters from NITK. I worked in companies like Intel, Philips, Samsung, and other companies. I worked in USA, I worked in Japan, I worked in South Korea, and all those things. And I was working in the top R&D teams across these companies. And this is a startup which not only does the training, but we also have a product. We also hire the resources for our own company. So we are developing a education platform using AI, interactive video, and also we are building a healthcare platform. And we filed so many patents on that. And we also uh, got some government grant. We are selected at NASCOM 10K. We are selected as top 10 hot deep tech startups. We selected as in Elevate 100 grant, like a lot of things we got actually. So this is a brief about us. And why we are focusing on this training program is mainly because in for data science and AI, there are huge demand and supply gap is there. If you see, this is an ASCAM report in 2018. The number of resources required is more than the number of resources are available. And so many startups are entering in this space, and everybody is looking for the resources in data science and AI, because data science and AI based companies are getting a lot of funds, and they are raising a lot of series A, series B, series something huge money, and they are running after the talented resources. So that is very huge. And since the data science and AI is dependent on the data, and the data is growing at exponential fashion, and the demand to analyze the data also is growing very fast, and resources to analyze data is also growing fast. And because of that reason, in future, like in next 5 to 10 years, then maybe around few crores kind of resources are necessary to address all the requirements of all startups across not only India, across the globe. And that is the reason a lot of institutes are started training people in data science and AI. So not because just like it is a fancy kind of thing. So everybody has predicted actually in next few years, like data science and AI will be very big, and they need a lot of resources. And that is the reason almost all institutes have started data science and AI. And this is the McKinsey report. It is saying that like some companies who are enabling data science and AI are making becoming a very competitive advantage compared to their counterparts, and somebody who's not adopting data science are losing to the companies who are adopting. That is the reason also the data science and AI adaptation across all domains are increasing. So why we are here is actually like to address this gap and fill this gap, and also enable the people, like, see what happens actually, like over the years the education cost has increased, but the basic initial salary is still the same. So earlier, like in 2020 kind of thing, in 2000 kind of things, like education engineering cost or any degree cost is like few thousands, and whole if you take entire education up to a degree, like around 1 lakh or 2 lakhs, everything will done. After that, like if students get like 1 lakh, 2 lakh kind of a job, it is still fine. But now the education has cost has increased multifold, and they need to get into a very high paying job. So that is the reason we wanted to train you people into the domain which is which enable them to get a very high paying job actually. So this is another reason we are entering into this space. About our program, so this is another one, in fact, a important fact actually. See how the companies hire actually. Company doesn't hire based on the your degree or like from which college or which branch or something. So take a company student of profile A from top-notch company, so institute, and take a student B of top-notch, but just focused on the academic thing. And if you see the profile of a C guy who is from ordinary kind of a college, but okay kind of academics, but he has done some kind of like done lot of certification, lot of mini projects, internship, hackathon, and all those things. See the profile like this actually. Companies prefer the students of profile C compared to the profile A and B. So that is the reason like we are also enabling all BCA, BSc, BSc Computer Science, B other branches actually get accustomed, like get learn these programs actually, and be competitive to the other branch students. So let us little bit go through our program. So the program is having around 8 skill sets, like basic skill, data science, analytics, Tableau and Power BI, machine learning, cloud computing, deep learning, natural language, and DevOps, and have multiple internships and mini projects and soft skills. If you look at actually the number of hours, like so we divide into 6 semesters, and number of hours what we train, it is very comprehensive. The curriculum is very much comprehensive, and it is if you see the comparative analysis with that, actually the quality of the program and what we teach, and how we teach, it is in line with the like what is called NIT kind of a curriculum. And apart from that, like see this program is all inclusive. There is no additional cost for internship, mini projects, soft skills, aptitude skill, placement support, everything is included. And even without this course, actually without this course, if you are doing the normal course, like you have to do internship and you have to pay outside, you have to do mini projects, you have to pay outside. Whatever you are trying to pay us, actually it is as good as like you are paying outside there. So that is another thing what we are trying to say. And another thing what we are saying is actually what we are costing you is actually 20%, and remaining 80% you will be paying only when you got very good job. And another value additions what we are saying, no, this is not for just for the course. Actually we are creating a community of data science and AI, and we will be supporting you throughout your career with the job portals, with add-on skills, actually like supporting your startups, investing in your startups, doing some kind of giving a lot of opportunity, freelancing opportunity. It's like this is a community we are building, and we will be supporting your throughout your career one or other way. So it is not just like a certificate and then you just I'm helping for one step job. Now it is a lifelong kind of a relationship we wanted to build actually. This is all about our program. So just I wanted to briefly explain about us before we jump into the deep learning. So anybody has any questions, let us know. So or else like I will switch into the curriculum. Okay. So anybody has any question here? Okay. Now let us start the deep learning program. So so as okay, I hope you people knows the difference between. So one more thing. So I am assuming that like all these all you are already have aware about the Python and already aware about Kaggle notebook or like Google Colab, knows about done some lot of programming. So I'm not covering all those things. If you are not aware about that, then I already shared you that YouTube links, channel links, where you will get those kind of courses. You can go through that and you can attend. but I'm assuming you already know that actually. So I'm not covering those things because I'm covering in respect to other models actually. So fine. So let us start with the program. So before jumping here, so let me ask some basic questions. So how many people knows what is why this machine learning or deep learning, why we call it as a deep learning, machine learns, why we call that? I hope you people knows it actually. So I just wanted to highlight what is, see, because so long we were programming, so there is something that like we know that like what is meant by program or programming. So we heard about programming, but now suddenly like we are hearing another term, what is called machine learning. What is this actually? Like this is also we have to do some coding, correct? Here also we should be doing coding, and here also we will be doing coding. Then what is the difference between the first and second? So anybody knows answer for what is the difference between the traditional programming and machine learning? Because in both cases we are coding. Then why we are calling one as a programming, normal program, another as a machine learning? Anybody can have any question, any answer for this? Okay. So let me explain that. See, for example, take one example. Let us take finding a prime number. So finding a number is a prime or not. Let us take one simple example. Take a number and we need. Okay, correct. Actually, like that's fine. So I will explain that actually. Like maybe others doesn't know. See, take an example. Finding out a number is prime or not. So number is prime or not is a problem. So is prime or not is a problem. So what? So prime or not. So how I am trying to do in the machine learning and how I am trying to do in traditional programming. So what is we will be doing in traditional programming? So first I should be understanding what is the input and what is the output. So what is the input? If I give input as 2, output is something that like, so is a prime. So if input is 3, output is prime. If input is 4, output is not prime. So this is what expected, correct? Now what we'll do, this is the input and output, and this is a problem statement. So next, so this is a problem statement and we understood the problem statement. Now what is the next? Actually in traditional programming, we need to write a logic for that. What is the logic for that? So if the number is not divisible by other than 1 and itself, so other by 1 and itself, then that number is called prime. So means like what I will be doing, so number is prime. So what I will be doing, so I will be starting with a 2 and less than that number. So less than that number is n minus 1. So every number, like I will be trying to divide that. So for example, x is a number. So I will be trying to do first trying to do divide by 2, then I will be trying to do x by 3, whether it x by 4 up to x by n minus 1. So then if any one element is dividing, dividing means like it is the remainder is 0, then I will be saying it is a not prime, or else it will be prime. So this is a logic, whole logic I am trying to do. Means like input is there, output is there. I have to write the logic. Algorithm I should be writing, and algorithm I should be writing, algo I should be writing, and then I will be converting into a program. Algorithm I will be writing, and then I will be writing into program. Program in any programming language. I'm not saying that like you should only do in Python or something. C, C++, any programming language you can do. But like since this all about Python and the data science and machine learning, so you convert that algorithm into Python programming. So that is called traditional programming. This is what we already know. So what is that actually? Inputs are there, and based on that input and output, I am trying to write an algorithm. From that algorithm, I am writing right program. So who does actually? Programmer is the one person who will be writing that program. And then what I will be doing, I will be feeding this program to the computer. I am trying to feed this program to the computer, and computer will execute this program. So what is that means actually? So I have written this program. So maybe I'll use a for loop or whatever other loop, and then I'll write. So what is that I will be writing this whole algorithm. So let me go here. So I will be writing this algorithm, then I will be writing the program. So program, maybe I'm not writing the whole program here. So assume that like I have, see, first I have written the algorithm. So then I have written the program for the prime number detection. So program I have written, and then I will be feeding to the computer. So I will be feeding to the computer. Computer will execute. So computer will execute it. Means like what? If I give another number like 6, so computer will give output as not prime number. So this is a traditional program. So the burden here is actually programmer will write an algorithm and has to write a program in a programming language, whatever it is. This burden is with the person. So programmer does that actually. A machine just blindly execute whatever the program you have written. So machine role is actually just to execute it actually. Then what is the role in machine learning? Machine learning, when I say machine learning, I am not giving the logic here. So I'm just giving this input, I'm just giving the output, and I'm asking the computer to write a logic. So for example, in this case, what I'm trying to do, I'm not, see, if you take this case, I'm not doing this, any of this actually. I'm just feeding, this is the input and this is the output. I'm just feeding, this is the input and this is the output for that. So I'm just feeding this input and output, and I'm asking computer to write this algorithm and the program. So it's like, what is the thing actually, what I'm trying to do? I'm giving input to computer and I'm giving the output to the computer, and saying that like this is the input and this is the output, and I'm asking computer to write the logic. So you are the one who writing the logic or the program for that or rules for that. So either you can call program, either you can call the rules or whatever it can be. So we ask the computer to write, and then what happens actually? This logic, like, so when I give input and output and asking computer to write a logic is called training. So I'm training the machine to learn. So and build a model. What is that model? That model is rule based model, or it is a algorithm, or it is a program, or whatever it may be. So this program will be built. Next, what I will be doing, this program is executed, same, because any computer is to execute program, correct? So program is executed, and then I will be giving a input 6, and then it will be saying it is a not prime or prime. So in this case, the logic, the responsibility of writing a program or a logic is lies with the machine. So what is that actually machine is trying to do? Machine is trying to do part of our role. What is that role? Writing a logical thinking and writing in a program, rules actually. So since the way we learn, we understand something from the observation, and we write an algorithm and then program executes. Here I am asking the computer, you do this activity, observe the input output, observe something, and based on that you come up with rules. So I'm not doing anything, you come up the rules and then do that. Is since it's machine is doing that, actually we are saying that like machine is learning the way we learn. So how we learn, we get some data and we'll try to do. So for example, another example, if I had to give, take an example of okay, this is a cup. Assume that like this is a cup, and how we'll see the we see the eye, and somebody says actually this is a cup. So means like there is an image, this image, and we say that like this is a cup. So is a label. So this is called label, or we can call this as output. So we are calling this as output. So if you see a image, this image, and we are calling this image as cup actually. Like means like we see the cup and then we say that this is a cup. And for another one, so this is a bottle, something that like. So we see the image and somebody is labeling it as a bottle. So what we do, this is the image, is the input. So we are giving this to computer, and the label is output. That is what we are giving, and we are saying that like the way we learn, no, we take an image and somebody says actually this is a machine, this is a cup, and another image, oh, this is a bottle, and oh, this is a chair, and this is a table, or something like that. Like we tell this subject is chair, this subject is table, this subject is cup, this subject is something that like. That is how somebody will explain, correct? In when you are in childhood, correct? Something similar to that. If we give this object, means like object, because since it doesn't have a eye, we are giving an image. So if you are giving an image to the computer, and we are giving the label to that actually, which is the object, what is type of the object actually, and I'm asking the computer to understand these objector and learn from that the way we learn. No, so somebody explains us, correct, initially, oh, this is called cup, this is called chair, this is called something that, like, now what we are saying actually, we are giving image and saying that, like, okay, this is a cup, this is something, we are helping machine to learn actually. So then what happens, then after sometimes when machine is learned and builds the rules or regular whatever the algorithms or whatever it is built actually, then if I give another one object, so then if I give that this is a bot, then if it is identifying it rightly, so identifying rightly as it is a bottle, then I say that actually machine is learning the way we learn. Anybody has any question here? Anybody has not understood this thing? So that label training is a supervised learning. Okay, so that this is called a supervised. Okay, we'll don't go into whether it is a supervised or unsupervised or something. So I'm just to give an example. So it can do anything. So we will discuss that in a later, because not we can't discuss everything here because this is a short kind of session. If you are wanted to go in depth about what is meant by supervised, unsupervised, and how things, like, then there is a detailed curriculum we should be going through, but I'm not going. But you are correct actually. The labeled training data is called supervised learning. So it is always called supervised learning. So why it is called supervised learning? Somebody is supervising, somebody is explaining. So see, who is the supervisor actually? Like when who teach us actually, our mother, our father, or one. So he's they will explain us. No, oh no, this is not called a cup, this is called a bottle. So no, this is not called a chair, this is called table. It's like somebody is surprising and saying that, like, whether I'm learning right or wrong. So here the label, since this label will say actually whether you are learning right or not. So if it's trying to identify wrongly, no, this is a cup, this is a label. So that is the reason label, wherever there is a label is there, that label guides the machine to learn in a proper way. That is the reason they are called it is a supervised learning. So, but we won't be going in detail about that actually. So any questions here? Like, understood the difference between the program, traditional program, and machine learning? Okay. So which one is easier for you? Is normal programming or a machine learning? Anybody can answer? So which were easy for you? Normal program or writing a machine learning program? Yeah, why? Because the whole idea of writing the rules, algorithms, everything is taken care by the machine. So only thing is your responsibility is find out the proper input and output and other things and select appropriate algorithm. We'll discuss that later on, but not because we won't be discussing here. Okay, to further enhance, so this is the same thing. So it can be anything. So yeah, I'm not saying only for object detection. So you take here another one. So this is another example of transaction is fraud or not. So means like, so some transaction happens. So means like somebody has withdrawn some money. So in one ATM one, so in ATM one, some withdrawal happen. So ATM one is at certain location. At ATM two, another withdrawal happen. ATM three, something happen. So our bank, somebody visited bank and withdraw something. So these are called transactions. So multiple transactions happened. So now I wanted to see that, like, somebody has hacked your account or something fraud or suspicious activities happened or not, how to predict. So that is called fraud detection. So what is this model is about? Fraud detection. So traditionally, if we have to do, so we have to do our own algorithm. So what is that algorithm? Oh, okay, if assume that, like, person is withdrawn on a ATM on a day one. So assume that, like, Monday at 8 p.m. he has withdrawn at ATM in Bangalore. So correct. So Monday 8:10, he can't be withdrawing from Delhi. So it is impossible to move from Bangalore to Delhi. Correct. So in ATM. So means like either this is fraud, either this is fraud. So any one thing is fraud. So means like these rules we should be like when the distance between two ATM and when he is like all those kind of rules you should be writing to detect whether it's a fraud or not. And more another thing is actually if, average withdrawal, if average withdrawal of a person, like every time whenever he withdraws usually lesser than 1000. All of a sudden if he is withdrawing something like a 10,000 or 20,000, you may okay, this is above the some average withdrawal person by the person. It's like you have to write all these logic to identify whether that is called. It's like in the traditional program, so transaction based understanding a transaction and which is fraud or not, then you are writing the rules, means like algorithm step by step, which is right one, which is wrong one. So this is a traditional thing. In machine learning, I'm just giving the transaction. Means like, for example, the ATM one transaction happened. So this is a transaction. I say that like not fat, and ATM two happened. So I say it is a fraud, and something bank withdrawal one, if it happens, not fraud. So something bank two statement, something like details about that actually, how much at which location, how much of money and everything. This is all called input. This is all input, and this is output. So I am trying to give this input and output. This is about information about the transaction. This transaction is like when the transaction happened, at what time happened, at what location it happened, how much money withdrawn, and all those things, information about this transaction. This is the input. So this is the input I am trying to give. Means like about the information about transaction. If you withdraw money, what are the information you will be doing? How, at what time you withdraw money, at what location you withdraw money, at which ATM you withdraw money, how much money withdrawn, which account you withdrawn, all those things. No, that is called information. So the transaction information. This is the input. And output. Output is actually like I am somebody saying that like this is right or wrong. It's like so this is the output. So who will do that actually? The either customer says actually this is my only transaction, so everything is fine. Somewhere else like he's suspicious that like I'm not withdrawn and something somebody has withdrawn, and he says that no, this is not done by me, this is spurious kind of thing. No, it's like you created, this is a okay, this is the right one, this is the fraud one, this is the right one, this is the fraud one. So you have given that. So now what you are trying to do, we are asking to machine to write a logic algorithm. So write in a rules actually. So that is how that done in the second case. So in second case, machine is trying to write an algorithm. So that is called, so it is much more easier for me to write algorithm. So that is what is the difference between machine learning and traditional programming. And it can be any application. I just gave the two application. There is no point in to explain all application. I hope anybody has any question here still not able to follow, let me know. Are you guys able to follow? Okay. The next thing is actually like this is all about deep learning. No? So now we understood the first. In the first case, actually rule-based things, everything is done by the program. So it's like we write algorithm and program executes everything. So this is whole thing is manual. Only computer role is actually just to execute the program. So very little kind of role. But in the machine learning, classical machine learning, so our only role is actually this one. So in the second case, I say no, transaction and the information. This is called features. So which ATM, which location, how much money withdraw. This is called features. So only I should be collecting those features and saying that like creating a data set. That is what is the data set actually? Data set is a feature things like ATM location is one feature, ATM location, and ATM what is called amount withdrawal. Amount withdrawal is the second feature. Amount withdrawal is second feature. Assume just only two feature, and this is called features. Like so, this feature extraction is like which feature is important to identify whether this is a fraud or not. So this is what I am trying to do. So in the machine learning, only my role is actually just generate this feature and data set and just ask the machine to do the all the writing the logic or like everything, like what kind of logic, what kind of rules it has to be right, everything is done by the machine. So the wherever we say blue, so that responsibility is not done by me, that is done by the machine. If you look for the deep learning, in deep learning we are not even doing that also. So which feature is important, all those things not necessary for me to. So everything is done by the machine. So if you see the whole blue thing, that is all done by the machine. It's like it is reducing my work further and further. So if you think about the first one, and if second the machine learning, and if you see the deep learning, further and further role and my role is reduced, and it made me to more and more easy to write the deep learning program. Any questions here? So we are not doing anything in even in feature extraction, not even doing the rules writing. So any question here? Anybody not understood? So that is the difference. But both are part of artificial intelligence, machine learning, deep learning, representation, everything is a part of like. So if you see the whole thing, so artificial intelligence is the superset actually, AI superset. In that AI, then there comes a machine learning, then there comes a deep learning. So then there comes a something like a NLP, natural language processing. These are all part of, and representation learning is also something in that only. So this is a superset. So all are learning. So artificial intelligence actually mimicking the human being intelligence. Like, so natural, ours is a natural intelligence, machine intelligence is artificial intelligence, because that is not a human being, correct? Not living object. So that is a super artificial kind of intelligence. So, and all this artificial intelligence is machine intelligence. So all these things comes under part of an artificial intelligence. Any question here? Anybody is not understood any of this? Okay. So this is just a contest, because since like some people are directly joining after Python, for them all these terms are very, very new. But somebody who already understood the Python and machine learning and all those things, for them it's much more easier. And somebody who's undergoing the full course, actually we will be covering this machine learning in detail, everything in detail, but like just I'm trying to give an overview here. So any questions here? Okay, so here onwards, like we will be switching to the what is called deep learning. So if you have any questions here, we'll let you. And one more information what I'm trying to say, there are two stages will be there in machine learning. One stage is called training the model. So we will be training the model. What we'll be training the model is like we are trying to create input and output data sets actually. So we'll be input and output. This is the one kind called a data set. And this data set I am trying to train the model, to train the machine learning model, and model will build a program, so or logic or something. And next this is stage one. Stage two, what I will be doing, so this program will be executed in the machine. So I will be giving another input, and this program will give the output. So what is the difference? Actually, this program is not written by me, this is written by the machine. So in traditional things we do. So here second phase, whatever the model is already trained, that I will be using to test the system. It's like whether you are giving the right output or not, the way we used to do in traditional programming. So first in traditional programming, only the second stage was there, that is the testing, because we used to write algorithm and we used to test the whether program runs right, executes properly, gives the proper result or not. But in training, in the machine learning or a deep learning or whatever it may be, there is one additional phase, because we have to give this input and output, and program is to be generated by, the logic has to be generated by machine. So that is a training phase, and testing phase is same as the whatever the traditional. These things you should be remembering. Any questions here? Somebody has any question? Difference between reinforced learning? No, we are not covering reinforced learning here. So we will be covering that in a later thing, because we cannot cover everything in this workshop, correct? Reinforced learning is another trend, another thing. But just if I have to give a simple example, what we will be doing is something that like a similar to our day-to-day life. So day-to-day life, what we will do? So for example, if your mother is a teacher, so mother is a teacher, and if I ask you to do 3 plus 4, if you do 7, oh, you have done right job, so one take a chocolate. So that is the reward I am trying to give. And if you do 3 plus 4, and if I say 3 plus 4 is equal to 5, so now you have done a wrong job, then I will be hitting you with a stick or something like that is a penalty. So reinforced learning is actually using this reward and penalty, reinforcing, enforcing you to learn proper way, so that the way teachers or your mother help you to learn proper things, correct? So that is somebody reinforcing you to learn, no, this is not right, this is right. So that is what the reinforce, like they will be using reward and some kind of a penalty, using that they will be teaching you. So they will be teaching you, so that is called reinforce. But I don't go in detail about what is meant by reinforce, and like just to tell that person. So fine. So okay, so moving on to any questions here? Any questions here? Okay. So okay. So this representation learning, if you have a concern, representation is like for anything you will be having a representation. So for example, how I have defined actually what is a Pragnan AI? Pragnan AI is a company startup selected in these things, started at this year, and one is the training vertical, another is the product vertical, and so it's like that is what I'm trying to do. I'm trying to board companies when it is registered, which location it is there, which domain it is working. That is called representation of a company. Means like to understand that company. So representation learning is like using those representation, you are trying to learn about that objective. So those kind of things, but I won't be going in detail about that, but it is something similar to that. We are saying that like a representation for every object, there should be some representation. Using that representation, I'm trying to learn about the object. So please mute it. Okay. So okay. So moving on to what is called deep learning. So from here onwards, we will be focusing on the deep learning, and then we will be focusing about CNN. In deep learning also, so many things are there. We are not covering entire thing. We are just covering the CNN, convolution neural network. So many things are there in deep learning. If you are enrolled the program, full program, we will be covering entire thing. What is meant by deep learning area, but here we will be only covering the CNN. What is the mean by CNN? So first introduction to deep learning, and then we will be switching to the what is meant by convolution neural network. So there are so many types of neural networks will be there. Deep learning will be there. ANN is one neural network. That is called MLP is multi-level perceptual neurons. So there is a CNN, there is a RNN, there is a GAN. So there is a GAN, and there is graph layer. Lot of things are there. Graph, NLP, and all those things are there. So if you are enrolled the program, we will be covering entire thing. But in this session, we will only covering the CNN here. So any questions here? Anybody has any question here? Okay. So now before moving and explaining what is meant by convolution neural network, so first what we understood so far is actually, if we give an image and we are saying that like computer has to understand about that object. So for example, if I give an image, this is a bird, and computer has to, so if I give an image and I will say here downside, it is a bird. But what I'm trying to say, I'm not giving extracting feature. So I'm asking that like you only identify which is the important features are there about the bird. What are the important features of the bird? So the beak, this is one, feather is one, leg is one. So all these things, correct? The shape of that eye is something that like, now these are the some of the important features of the bird, correct? So now we don't know where exactly this important feature, because image may be anywhere, correct? So there should be some mechanism to recognize, identify and recognize those important features. So it's like, so I should be looking here, this area, and I should be identifying this is a beak, and I say, okay, I detected a beak. So how should I identify this is a bird? So if I have to identify the bird, what are the characteristics or representation of a bird? Bird should have eye. I should detect an eye. So bird should have a beak. What else? Bird should have wings. So what else? And bird height should be something, some height and width or whatever it may be. And what are the other things? Color. So tall, tail. Okay. It should have a tail. So it's like what I should be doing, I should be able to figure out in this image. I should be able to figure out is it has an eye, it has a beak, it has a wing, it has a tail and legs, correct? So it has how many legs? So only 2 legs, correct? It has to be able to identify that. So how we will recognize an image? So if I show you this image, you will, I will ask you that like identify what is that actually. You will definitely identify. While identifying, what you will do? You will look actually. Oh, this is a bird. How you come to know? You look all those features, correct? So if it is a tiger, then you look all those features, how the tiger looks like. So you remember those features, key features about representation of features which represent tiger, correct? So then you will try to figure out whether that present or not, and then you will try to recognize. So something similar to that, because I am saying that like machine learning or deep learning, everything is mimicking the way we think. So it's like they should also try to identify those features which we used to look, correct? So suddenly you cannot say that like suddenly it is a bird, correct? You also look those features, correct? So when you if I give an image, Then if you say that like identify what is this actually, you will look for those features, correct? Directly, you cannot say that some without blindly recognizing features. So something similar to that, machine also has to recognize, extract those features. Like if you see actually in deep learning, I'm not doing that. The machine has to recognize that feature, and then it has to come up rules, and then it has to identify this is what kind of object. So basic thing is actually I should have some mechanism to identify these features. Means like what is this feature? I should get this small region. I should look for this small region and identify this is a beak. So I detected a beak. So how should I recognize? Okay, in this image, I detected eye. In this image, I detected beak. In this video, I detected wing. In this image, I detected tail. And height is with this much, length is this much, and two legs. So all these things, okay, means like if I detected one by one by one by, my percentage of identifying this is a bird is increases. So only I detected eye, so I'm not sure if it is a bird or not. So maybe 5% I'm sure. So if I detected a beak, oh, my percentage will increase to 10%. So now if I detected tail, then percent become 15%. So then I like height, width, length, all those things. My percentage keep on increasing, and when I get every component, every representation right, actually, then I will say this object is a bird. So fine. Is there anybody has any question? Anybody not understood this? Okay. So we need to find out some. This is called small patterns, small patterns. I should be able to recognize in the image. And another thing here actually, see if you take this image and if you take this image, so this pattern may be right corner. I don't know where exactly this beak will be there. It may be here, 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 anywhere. No. See if it is tilted like this, you are tilted like this. So image may be anything. So that this pattern may be anywhere in the image. So that you should be remembering, correct? So you should know that like where exactly. So here in this case, the beak is at upper left. Here it is the case, the middle thing. So I need to, I say I don't need that location, because is anything like this cannot be bird, this can be bird only if it is upper left? Is anything something like that actually? If the beak is only in the right corner, then only I can say a bird. No. Yes or no? It can be anywhere, correct? So I should not differentiate. This and this are both are same, correct? So my machine should not get influenced the presence of that pattern anywhere in the image. So I should be looking everywhere in the image. My whatever the feature I should be looking at to identify this is a big. First of all, I should identify which are the features are very important. Second, whether those features are there in the image. And if I get all those features, then I will classify, or I will say that actually this image is of bird. Is it fine? Any questions here? Anybody has not understood this? Okay. So how much time we have? Okay, another okay, 7:30 to 10:30. Okay, oh, 8:35. So we have some more time. So now what we need? So now to identify this feature, if we identify this feature, I need a mechanism to look after the entire image. How should I look into? So for example, what I said actually, this is the image. So beak may be here, beak may be here, anything. So I need a mechanism. So I should first look into some portion, then I should look into some more portion. It's like I don't know where exactly it is there, correct? Machine doesn't know, because you can visualize, but machine doesn't visualize, because you cannot feed anything. So only just you are feeding image and you are saying that object, but you are not seeing that like where is the beak or something, nothing will be there. No, machine only has to identify. So it will keep on searching. So first it will look into here. Okay, anything useful I got, which I should be able to, means like which represent image about the bird, I am not getting. Then I will look into here. Then I will look into here. So no, I didn't got. So means like this has to keep on sliding. So this is called. So what is that actually? This is called convolution. So this mechanism is called convolution. So this small portion, looking the small portion over the entire image. It's like you are convoluting over the image. That is a mathematical term that is effect used if you are a electronics engineer and you would have studied actually what is meant by convolution. So that term is called convolution. Because of that, the word comes convolution neural network. Neural network is actually what we are trying to do. Using neural network, we are trying to build models, correct? So, so that is called convolution. So what is that convolution means? Convolving over this image is convolving over the image. Means like it will be initially it will be here. So it will be here means like what is that actually? It is trying to identify. So it is trying to identify certain information, whatever the information. If I'm trying to detect a beak, okay, I am trying to detect a beak. Or if I'm trying to detect a tail, so whether the tail is there or not. If I'm trying to detect a wings, so whether wings are there or not. So I can detect any feature. So I'm not saying that like only that feature. So whether that feature is a if it is a filter is for beak, then I will check beak is here, no. If it is here, no, yes or no. If it is here, if it is not there, it is here, so it is here. So it will check entire image. So then it will come here. So then it will come here. Then it will come, it will check here, it will check here, it will check here, and it will check here, and it will check. So it's like next, it will check here, it will check here, it will check here. So this is how this whole thing works out. So what is that actually? This process is called convolving, convolving on the input image. So what is that actually? You are, this is something just like a small window. It's like you look into a small hole and trying to find out everywhere, because you can't look into, no. So if you entire image, there is no point into. All we are looking at a small portion of that image, correct? So I'm trying to identify. So what is this window size? You can decide. You can say 3 by 3 window you look into, or 5 by 5 you look into. So it is all square kind of thing. And rectangle also possible, but mostly we'll use this filter that is called what we are trying to convolve over the image. That size we should be fixing. So that size may be 3 by 3, it may be 4 by 4 by 4, it can be 5 by 5, 4 by 4, 5 by 5, it may be 5 into 7, whatever it may be possible. But usually we take square kind of thing, and we usually take odd number windows. So that is how trial and error method that gives the best result. So you can try out anything. There is no restriction that like this window, what you are trying to convolve, this filter, this is called filter thing. This size may be anything. So what is this 3 by 3, 4 by 4 and all those things? So let me explain that. If you know the image, so when you say that like when I'm looking for an image is something that like image will have a size. So something like 224 by 224. What is this 224 by 224? The pixels. So you heard about pixels, all those things. I don't go in depth about the pixels. If you know, if you don't know, every image is represented by lot of pixels. So pixels. So how many pixels? Horizontal pixels is 224 and vertical pixels are 224. Means like this is the matrix of 224 by 24 pixels. It's like each pixel will have one color combinations. Like so, it may be of which different colors. How many colors are possible depending on what is your resolution. If you're HD, then there is a different number of colors is different. If it is a normal RGB kind of image, then the pixel values will be different. If it is a grayscale, then the pixel values will be same. So this is, if you look about the color and all those things, I won't go in detail, but all colors will be combination of red, green and blue, certain percentage of red. It's like they will have some color value. So usually how it will be stored? So color will be stored as a number. So that number will say how much percentage red, how much percentage green, how much percentage blue. So that is how the represented. That is called a pixel. So that is called a pixel. So and how many pixels will be there? 24 by 24 means like so, 24 by 24 pixels will be there in an image. When I say image, so I will be saying that like okay, what is the image size? What is the size means how many, how what is the width and what is the height? It is in terms of pixels, not in terms of inches. Image will be measured in terms of pixels. So what is that pixel? Pixel, one pixel will have one color. So what is that color? Color is a combination of certain RGB values. How much is RGB? Every color is created by using three key colors. What is the red, blue and green? So RGB. So it will have a how much percentage R, how much percentage. So it will whatever the mixer combination, it will give a different colors. Pink, red, all these colors are created using this combination, and this pixel value is that value. So RGB combination values, and the size, how many bits is necessary, that I don't want to go in detail, but each pixel will have some details, all of things that I'm not going there. But here intention here is actually 224 by 224 pixels will be there. So now when I'm saying that like the filter I'm trying to create, by 3 by 3 means like 3 by 3 pixels. Means like it only look into 9 pixels at a single moment. Means like I will only look into 9 pixel and I'm trying to find out whether the beak is there or not, or something is important feature is there or not. You can be this is called a filter or kernel. So which I'm trying to convolve over the image. Convolving means like moving around this image. This is this is called convolution or convol. So this is the convolution. So now what I'm trying to do, I'm trying to slide this filter and trying to understand from that how exactly it happens, that I will explain later on. But the size may be anything. So I'm just using 3 by 3. You can use 5 by 5. You can use any number. So but square is also fine, rectangle also fine, but usually square is preferred, and usually odd numbers are preferred. Means like 1 by 1, 3 by 3, 5 by 5, 7 by 7, 9 by 9. That is the preferred kernel size. So any question here? Okay. So what happens actually after seeing this filter? So something that like filter means like you see a filtering means like your glass. No, you will be seeing some whole glasses and then seeing that like outside world. So something similar to, then what happens? Whatever we saw, that I'm trying to represent here. Means like output I have seen here, and that output I'm trying to represent here. So filter will give an output. How it will give an output? Take an example. So this is a 6 by 6 image, means like 6 by 6 pixels is there. And my filter, assume that this is my first filter. So values are in filter anything. So 1, 1, 1, and rest all is 0. So how the convolution happens? So this 1, 1, 1, if I'm going, I'm sitting here, I'm trying to multiply with this. So this 1 is multiplied by 1. So value is 1. Minus 1, 0. So 0. So means like what I am trying to get is actually 1, 0, 0. So and 0, because minus 1 and 0 is 0. So 1 and 1 is 1 and 1. Means like I will add all these things like 1 plus 0 plus 0 plus 0 plus thing, and this is called sum of the values. So means like I am trying to do dot matrix. If you are understood the dot matrix, it will do the dot matrix. So anybody studied the dot matrix in mathematics? So it uses a dot matrix mechanism to find out. It's like what is that actually? Dot matrix way of multiplying the matrix. It's like this is a 3 by 3 matrix. So this is also 3 by 3 matrix, and I am multiplying. So this point to this point. So this is point 1 to point 1. I am multiplying. So what is the result? I am putting here plus point 2 to point 2. So point 2 to I am multiplying here. Result I am putting here. Then plus 0.3 to 0.3. So whatever value will be there. So I am adding here. Then plus. So something like that. This is called dot matrix. This is called dot matrix. So if you don't understand, you can refer the dot matrix. Convolution does the dot matrix. After doing the multiplication, whatever the value you got. So what value got actually? If you see here actually 1, 0. So rest all will 0. Only this will be 1 will be there. This 1 will be there. This 1 will be there. Rest all will 0. 1 plus 1 plus 1 is 3. That is what I have done here. If you see here actually, the dot matrix products is 1 per. Then the second one is actually convolute. No, this filter is initially from this location to this location. Now it's shifted to from this location to this location. So here 0, 0, 0. Entire thing is 0. So entire thing will become 0. So here minus 1 and 1. Minus 1 and minus 1 is minus 1, and rest all is 0. So then here 0, here minus 1. So 0 and minus 1 and 1. What is that? Minus 1 and minus 1 is actually 1 into 1 minus 1. So here minus 1, here minus 1. So 1 and 1 plus 1. So minus 1 plus minus 1 plus minus plus 1. So output is minus 1. So what is the result actually? I will be doing first one minus 1 plus minus 1 plus 1. So this goes off, then output is minus 1. This is how the convolution dot matrix result will be there. And if you slide further, then again, so you will get it actually. So what I'm trying to do, I'm convoluting this filter over the image. This is the crux of convolution neural network. Anybody has not understood this, what is the convolution and how the value is created? Anybody has any question here? Any questions here? How I have calculated? So let us try doing this one. So if I convolve here in this image, so what would be the output in the first location? If I am trying to put this filter here, what would be the output? Anybody can answer this question? So I'm using the filter second, this filter, and what would be the result? Anybody can answer? Answer is one. Only one person. Okay. So okay, let me do one thing again. So what I will be doing? So what is the value here? 10000100001. So value here in the input image is 100. Here 100 and 001. This is the input, correct? So I'm just looking only this portion, part of this portion. So first I will be convolute here, correct? Then the what is the filter? Filter value is -1 1 -1 1 -1. So -1. So same thing, -1 1 -1 -1 1 -1. So if I do dot matrix here, this is the dot matrix I should be doing. So how should I be doing? So let me do this dot matrix. So -1 plus 1 multiplication. If I multiply that, actually it will be -1. So 1 -1 into 1 -1. So then plus 1 into 0 0, 1 into minus 0 into -1 0. So I am not doing anything. So -1 into 0. So see, -1 into this 0. So 0. So 1 into this 1 into this 1. So 1. So I'm adding here. So this -1 into 0 is 0. I'm not discarding it actually. This -1 and 0 into 0. So this is also 0. I'm discarding. This 1 and to this 0 also I'm discarding for 0. So this -1 and this 1. So is -1. So -1. So what I'm trying to do, this -1, this -1 and this +1 goes, and the output is -1. So fine. So this is how the dot matrix is created. So the value is created. This is how the value is created. Any questions? So anybody is like how the dot matrix is done? Okay. If you want to do the next one, how I will be doing? Next one is actually this is 000100001. So then what is the output got changed actually? Here the output got changed. Let me write into another one. So 0, it is input got changed. Filter will be same, correct? 0 0, all are 0. So all are 0. Okay, let me go here. All are 0. Here 1 is there. So rest, this is 0 0. So next actually this is 0 1 1 1 1 0 and 1 1 1. So here 1 also is there. So this is the next filter. So if you multiply, then you will get the what? Anybody can try. This is 0 here, 0 0. Now you can multiply and see that like what is the result. Anybody can attempt. What would be the dot matrix value? So this is how it will calculate. So it will calculate that value. So what happens actually? So this is how it will create. So first one location I got this one, second I got this one, third I got this one, like that only it will keep on doing. Finally what happens actually? So I got this from this one I got this output, from this one I got this output, from this like this is how this is the output. So this is the input and this is the filter. If filter convolute over this input, so this is what I got. So this one for each one I should be multiplying the entire thing. So for this I should multiply. This is the output, this is the input, and this is output, and this is the filter. So any question? Please mute. Okay, fine. Okay, good. Let us move. So now you understood how the output is created, correct? So it looks into the image, convolute over the image, and it will create the output. So one by one. So this is how output will become. Like let us take it a example. One simple example will take. So 5 by 5. So assume that like 1, 2, 4. This is 1, 2, 3, 4. Okay, this is a 5. Here we'll have 1, 2, 3, and we have 4. So this is 4. Then this is have a 5. So this is a 5 by 5 input matrix, correct? So now my filter is 3 by 3. So my filter is 3 by 3. So my filter is 3 by 3. So now what is the output here? So now what happens initially? So initially one output I will be getting from this one. So this will be represented, sorry, this one, 3 by 3, correct? So first one is this one. So I will be convoluting, this will be convoluted here, and for this represented by one single dot, some output, whatever it may be. Next, what happens actually? Next, what it will do? So it will convolve. I will use different color. It will convolve over here. So this is the reason it will look into, and it will create another dot. It will create another dot here. So next, what it will do? It will convolve over another reason. So this is the another reason. So this is how it is convolve over another reason. So it will create another one dot. It's like I have created 3 dots here. Now, so it is done here. So then it will come down. So how it will come down? So it will come down something like this. So it will come down something like this. So it will come here. So this is the one. So it will represent one more dot here. So one more dot here. So next, what happens? Now it will start sliding here. So it will slide. So it will start sliding something like this. So it will give one more output here. So this is the dot. So next, what will happen? This is another last thing. So it will convert something like this. So then it will give another dot here. So now what happens actually? This is all turn is done because there is nothing is there. So it will come down. So what is that actually? It will come down. So then how it will come down? It will come down something like this. This is the first it will look into. This is the first angle look into, and it will represented by one dot here. So next, what happens? So okay, now it will start sliding. So it will slide something like this. So it will start sliding something like this, and this will be represented by another dot here. So next, finally, it will come to here. So then this will be completes. This is the last slide. So it will dot another dot. So after that, there is nothing is there down. So it will stop. Means like what happens actually? It generate one output here, second, third. So third, 3, then here, here, and here. Means like here, here, and here. So what happens actually? This 5 by 5 input is reduced to 3 by 3 output. Is it clear? Is anybody has not understood this? So because of this filter, it is looking about 9:1. It is looking 9 pixel and generating one output and convolving over the image. The input image, this is the input image of 5 by 5, and this is the filter size 3 by 3. And the output is what? 3 by 3 image. This is fine. Is there any question here? Anybody is not understood this? So what we understood here, whatever, see, if you do convolve over the image and we are trying to create, so we will be a little bit like reducing the size. If you see here actually, what is the size here? 1, 2, 3, 4, 5, 6, 6 by 6, and this is 3 by 3. And what is the output? 1, 2, 3, 4. So it's like 6 by 6 is reduced by 3 by 3. Okay. So now what happens actually? Like now what I have done. So first one, what we looked into 5 by 5, 5 by 5 input after convolving over the filter using this is a filter. Output is 3 by 3. This is what the output we got. So another one is actually 6 by 6, 6 by 6 using 3 by 3 filter, 3 by 3 filter. What we got output is 4 by 4. So as per this one. So what is that actually here? If you see, this is 4 by 4. This is the input and this is the output. Sliding one means like I'm just sliding one only. So either this horizontal or vertical. I'm at a single instant, I'm just sliding one. So I'm not sliding two. Sliding two means like if I say sliding two, so this is about for sliding one. So this is output for sliding one with this kernel. This is the output. This is the input. So what is we understood? Whenever we use a kernel, it sees a input, it generates output, but output size is lesser than the input size. So how much it is less? So if you see here, actually 5 is reduced to 5 by 5 is reduced by 3 by 2. It's like 2 is deducted here. So 2 is deducted here, 2 is deducted here. So 4 by 6 by 6 is reduced by 4 by 4. Means like 2 is deducted here. 2 is, why only 2? This 2 is from 3. If it is 3 by 3, then 2 is deducted. If it is 4 by 4, 3 is deducted. If it is 5 by 5, 4 is deducted. If it is 7 by 7, so like that is how the relationship is there. That is a pattern is there. So if I give the extension of this problem, so let me try to give the problem. If assume that the input size is 100 by 100, and I am trying to do slide 1. If I am trying to do slide 1, so I am trying to do slide is equal to 1, and filter size is 10 by 10. What would be the output size? Anybody can answer? So already I explained, and I wanted you should be giving answer. What should be the output size? This is input size. This is input size. This is a filter size or kernel size convolving over this one. And what would be the output size or feature map? This is also called a feature map. So what is the feature map size? Any question? Anybody can answer? What could be the output? If you still want to see this diagram, okay, where was that actually? Another one. Okay. You see this one, 5 by 5 is reduced to 3 by 3. And you see this image also, 6 by 6 is reduced by 4 by 4. But we use the 3 by 3. But in this case, what we are using is 10 by 10. So anybody can answer? Anybody can attempt? Okay. Any guesses? Okay. Let me re-explain the same thing. Now, if we have an input size 5 by 5. So now my filter size is 3 by 3. 3 by 3 is a filter size, and it will convolve over this input, and stride is 1. So that is what is that. What we got output, actually, we got output as 3 by 3. This is what we got, 3 by 3. How we got that we already explained. So it will look into here, then it will represent one bit here, then it will look into here, and it will represent one bit here. So it will look into something like this, and it will represent another bit here. So this is how we got. Now another thing is actually 6 by 6. 6 by 6 is input image, and with 3 by 3 filter, so we got output 4 by 4. So that is what we already saw here. Now what is the pattern here? So input size is 5 by 5, filter size is 3 by 3, then output is something like this. So input size is this one. What is the pattern here? What pattern we are able to understand? So pattern what we are trying to understand here is actually is something different. So how I'm trying to do? Let me give an equation wise actually. Like I want you should be coming up the equation, but I'm trying to give equation. So for example, the size is 5, filter size is 3, and plus 1. What we'll get is actually 3. So if size is 6, filter size is 3 plus 1. So what we get is actually 4. So means like 5 by 5 means like 3 by, so means like 1 5 we converted something like this. For another 5 also we are converting. So another 3. You are using, so there is a 3 by 3. No, 1 3 we used here, another 3 we are using here. 5 by 5. No, 1 5 we are using here, another 5 by another 5 you are using here. So 3 plus 1. So then it is reducing into 3 by 3. So now 1 6 6 by 6, correct? So 6 by 6, so 4 by 4. Now can you attempt what would be the result here?
Excuse me.
Yeah. one value or it will be two values? Is correct. The number what you are trying to give is correct, but yes, because it is a matrix, correct? It is a matrix, correct? Yeah, 91 is fine, but value should be matrix. So two-dimensional, correct? Output will be, why will be adding at least last one? Okay, this is a pattern I'm trying to do. Okay, let me ask you that, like, how you will relate. So you should be finding out the pattern, correct? So 5 by 5 is becoming 3 by 3. This is what we observed. So equation I am trying to create. Why not by seeing the result? I am trying to create an equation. It is not that like by equation it will work. So I saw convolution and got the result. So how you will be writing algorithm? You see input and output. Now what I saw actually here, let me take another one. Okay. What I saw actually 5 by 5, if I multiply convol over by 3 by 3, this I got output I got is 3 by 3. So how I wanted to find out a relationship between them. So this relationship I come up as an equation. It is not that like my thing. So that is the equation why added last. Or else like you can say, see, you have to come up an equation. So I have given two input, two output, correct? So using that, you should be deriving the equation. So that equation is derived. Just to remember, I actually like you should not be remembering equation. You should know that like whatever it will be -1, that much you should be reducing. So that is the equation, because that is how it will be coming. That we have proved with the examples. So you do convolution, that why you will be convolving. If you convolve like that, 9 will be represented by 1, correct? So if that can be experimentally proven how the output we are getting, and that you can even come up in equation and derivation, everything, but that I'm not going into. For everything there is a derivation is there. All convolution, everything mathematics, see whatever I'm trying to explain here, for everything there is a equation, derivation, and then the result. But I'm not going that equation and derivation because it will be much more boring, and finally it will come result into. So convolution dot matrix you can derive and you can get into what would the output size. So you can come into that equation. So fine. So anybody's any question here? Okay. Let us move on to then. Now next question comes actually, what happens if the stride is equal to 2? Stride is equal to 1, we understood. What happens if stride is equal to 2? What is stride is equal to 2? I think we will end here. I think it is already 8:42. Okay, I will complete this actually. Stride is equal to 2, then we will end here. Maybe tomorrow we'll take the channel, red channel and all those things we'll take tomorrow. Okay, now what we understood is actually first one. Okay, I will erase this. Actually this diagram we know, so I will erase this. Now I will take the same thing. So what is the same thing? So 5 by 5. So if I take 5 by 5, so this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 5. This is 1. This is 2. This is 4. And this is 5. Now, so this is the input size. So what is that actually? Input size is 5 by 5. So this is input size is 5 by 5. Now I will take filter size is 3 by 3. So the same thing. So 3 by 3. But now I will be looking for slide is equal to 2. So slide is equal to 2. Now how it will work? So for 3 by 3 is actually this is a 3 by 3. This is a 3 by 3 filter. So now what happens? So now first this will look into. So first it will look into fit into the 3 by 3. This is a 3 by 3, correct? So this is a 3 by 3. So it will look into, and it will multiply this, and it will result into one dot value. It will result into. So that is what you have put into. Now slide is equal to 2 means like I am not going here. I will be going here. So my slide is 2 means like I will be coming here. So I will be coming 3 by 3, something like this. So now it will be this one, and this will result into another dot. So now what happens actually? I cannot move here because that is dead end. So I'll stop here. Now what happens? I have to move downside. So this is how I will be like I won't be moving here because slide is equal to 2. So I will come and slide here. This is how I will be sliding. So this is represented by one dot here. So after doing dot production, we will get only one, correct? So that is what we discussed already, correct? Dot matrix. So dot product, correct? Now slide 2. So I won't be sliding here. I will be sliding here. So okay, I will use different color. Okay. So I will be sliding here. So this is how I will be sliding. So then I will be representing. So this dot, I will be representing this dot. So what happens actually? This 5 by 5 using this 3 by 3, but slide 2, the output size becomes 2 by 2. Output size becomes 2 by 2. So what happens actually? Output size has become 2 by 2. So this is how the result. It's like now same thing if you want to try it for 6 by 6. If you try by 6 by 6, actually what would be the output? So if you do 6 by 6, what would be the result? Anybody can answer? So now I have done for 5 by 5. Can anybody try with 6 by 6? Remaining is everything is same. Image size is 6 by 6. Yes. So it is a 2 by 2 because what happens actually after this it doesn't go. See, if even if the one bit is here, so I'm not able to switch because next switching is beyond that. So I cannot go here. So it is 2 by 2 only. Once even if it is 5 by 5, slide is equal to 2, then it is a 6 by. Much like now you should be coming up with equation. So what happens actually? So now you come up with equation 5 by 5, 5 by 5, sorry 5 by 5, convolution by 3 by 3. Then what I got is actually slide is equal to 2, slide is equal to 2, then I will be getting 2 by 2. So now 6 by 6 image, 6 by 6 image, same slide is equal to 2. So and the filter is same. So I got 2 by 2. So how is that equation? So now you should be coming up. So how I am trying to calculate? How I am trying to calculate? So what is that relationship actually? So now you should be coming up. So how it usually it will be something like this. Same thing 6 minus 3 plus 1 divided by 2 usually. That is how it will be there, and it is a floor. So you will be taking floor. So floor means like lower side. So 3 plus 1 is 3 plus 1 4 2. Here 5 so floor or sale actually you can say minus 3 plus 1. So what is that actually? Divided by 2 means like this is a 2 plus 1 3 by 2 means like this is a ceiling actually. We'll be taking a ceiling of that because there is no decimal point, correct? So we'll be trying to take that actually. That is how I should be getting into this equation. You can derive into. So usually this is how the sliding will happen. And there is a equation will be there. You can find out that equation. You can calculate, but you should be knowing that like how the slide works. So is it clear? Any question here? How the slide means? Anybody has any question here? How this number comes into? And if you want to try out, you can try out with the 7 by 7 also, but it is very tedious work. So having remembering equation is fine, but you can try out with 7 by 7 also how it works. So only thing the difference between the thing, rest all is same. The slide adds actually how it will be shifted. So it is not coming here. So 2 is remained. So if it says slide is 1, so next will be here. Slide is 2 means like next will be, it will start from here. So next again it won't start from here, it will start from here. So something like that is a slide 2. Slide 3 also possible, slide 4 is possible. So that is how it, anything you can do. But what happens actually? Slide, if you are trying to do means like you are trying to do something like this. So what is the impact of the slide is actually, so you are not looking in a proper sense actually. You are like, see, you are not clearly looking. So you are looking here and then you are looking something like this. If you are saying slide is equal to 3. So means like this is 3 by 3, correct? So 3 by 3, slide is 3 means like you are looking here and then you are looking here. So here there is no overlap. 3 by 3 filter with the 3 slides means like actually there is no overlap. So if it is 1 slide means like there is overlap will be there. 2 slides still there is overlap, less overlap. So if it is 4 by 4, 3 by 3 slide filter, 4 by 4 slide means like there will be gap will be there. Means like you are not watching entire thing. So it will be something that then you will be skipping here, then you will be looking here, then you will be skipping this. It's like you are not looking entire picture properly. So slide one means like you are looking the proper thing. You looking very smoother way. Slide two means like jumping the things. Actually, the impact will be different effect. We'll see how the impact happens. Any question? Any question on the filter? So any question on the kernel? What is the kernel and what is meant by dot matrix? So how it is be calculated? So what is the dot matrix and how this result is come and how this value output is derived? So and why we are trying to do this one? We are trying to find out certain features. So because that feature may be anywhere. So I'm trying to look into. So I'm trying to look into, but how this beak is identified, that we will look into later on when we build a model. So I'm not building right now model. When you build a model, image model, when you see the how the output, how the neural network is looking into visualization, you will come to know that like how the machine is trying to identify the beak actually. But right now you assume that like there is a filter. So if you want to see that like how the visualization looks like, I will try to give a link. You will see that like you will see that like how the result looks like into. So this is the one link I will try to give. So you can look into this and it will try to get into a clear kind of slow details. Like so this is the image, correct? So you will try to see what it is trying to see, how it is trying to show, and how things are getting identified. This is the one it will try to explain, but I'm not interested to show you this right now because I need to need to tell a lot of other things like convolution I told, but I'm not told about ReLU. I'm not told about input. I have told. I'm not told about channel. So when I explain this, then I will ask you to go through. So this is where you will come to know about like how exactly the visualization happens. And this is the one place, and this is another place. So you can look into how the visualization, it's like the neural networks are trying to learn from the system. This is another place. So you will try to write to. So you write to how this first layer, second layer, how they are trying to understand. So everything you will come to know here. So input layer, so then convolution layer, what the convolution layer one is seeing, show the, it's like this is, we will see this in a later on side. But right now you assume that like only convolution, then we'll discuss that into later stage. So any question here? If still if somebody wants to look into, they can look into, but anyhow I will be explaining later on. So any question on the convolution, what is in the convolution, what is meant by dot matrix, how the value is created, and what is meant by stride one, what is meant by stride two, and what is the thing, and this output is called feature map. So any question here? So next I will try to tomorrow session I will try to explain about the what is meant by channel and a lot of other things actually. So any question? See, I am going a little bit fast because I have to complete a lot of things in a shorter duration in 15 days. But I am skipping a lot of things because it is about just workshop, just to give highlight. But if you are looking for a deeper kind of things, like maybe we need to attend the proper sessions with individual, because I cannot take one explanation for one day actually. So that will take a lot of time. I wanted to cover as much possible as in the 15 days. So I need to cover the CNN in 7 days, and I will give an assignment, and then I have to cover Keras programming in 7 days, 5 days, and then I have to give assignment. Then I have to cover the PyTorch in 5 days. Then I have to give an assignment there. Like that is how the workshop is there. Any questions here? Anybody is not understood anything, you can ask me. So this is a foundation. So you can ask me because tomorrow's thing will be dependent on what you understood today's session. So any
can you give the PPT?
PPT and all those things I'm not giving because this is a free session. No? So videos will be recorded, videos will be there, but PPTs won't be given because I don't want people to have actually like, so videos will be there, PPT won't be there. PPTs you can refer anywhere. So PPTs won't be available. So sorry about it. So any other question? Recorded sessions will be available. So this is the foundation. So first and foremost question, if you are going to attend anything and something like, they will ask you to explain the what is meant by convolution, why convolution, and how the convolution works. This is what you should be explaining. What is input, what is meant by filter. Filter means like I will explain filter in little bit later on also. But right now you think about filter is something that like whatever the matrix I said. So that filter also, it is randomly generated number. So it has some meaning, but I will explain like how the filter, what filter will extract what information, that I will explain in the later session. But assume this is a random number and you are trying to do understand. Just I'm trying to understand convolution. Is fine. So this is a very these are basic questions they will be asking you if you are going for an interview about what is meant by stride and how the stride is impacting the size of the feature map or output. So that they will also ask you and explain you. So these are basic things they will ask. And what is meant by feature map. So these are things we covered today's session. Tomorrow session I will be covering about multiple filters, what is meant by channel, and I will be covering how exactly one neural network, convolution neural network looks like, and what all different layers. This is called a layer actually, like what is meant by layer and all those things I will explain. And fully connected layer, everything I will explain. When I explain all these concepts of the convolution neural network things, and I will give a small problem to write a small convolution layer and using the Keras. But next session I will be explaining how to write a Keras programming. So this week, whole thing I will be explaining CNN in detail. Detail means like as much as possible, because I cannot go in detail within the 4 sessions actually. How much possible to convey, what are the important concepts I will be covering. Fine. Okay. Thank you for your time. See you tomorrow. So sessions will be every day 7:30 to 8:30, but today I took a little bit more. So usually I will restrict it 1 hour, 1.5 hour maximum. Any questions? Yeah, recording will be there at our YouTube channel. So I said, so recording will be there. So I think I will also share that YouTube channel. You can look into all the, means like some of the informations, whatever I'm trying to take these workshops. So workshops recordings will be there, but materials and detailed sessions and everything will not be there, because we also, somebody who's undergoing the program, they will be getting that actually. Yeah, I will share you the YouTube channel link actually. So tomorrow session I will be sharing you. So YouTube channel link. So all the I think I have shared in your email, correct? So YouTube channel. So all videos will be available there. Okay. So it's not coming. So I'll give tomorrow. Okay. Again, switching back to my original account. Okay. Thank you. See you tomorrow.